Welcome to another episode of Science Made Simple. I'm Siew Qi and I'm a science specialist here at the Pique Lab. In this video, I'll be analysing a past year examination question on the topic of atoms, ions, and molecules. I've also prepared the question for you to download for free by clicking a link in the description box below. So, let's get started. Question 3. The electronic configuration of an ion is 2,8. What could this ion be? Now, before we start solving the question, let us do a bit of recap on atoms as well as on ions. Do you still remember what is the trait of an atom? We say that atoms are electrically neutral. What does this term electrically neutral mean? Well, this means that atom will have the same number of protons and electrons. Why is this so? We know that the protons are positively charged while the electrons are negatively charged. So what do you think will happen if we have the same number of protons and electrons? The positive charges of the protons will balance out, or we can use the word cancel out the negative charges of the electrons. So what charge will your atom end up having? Your atom will have 0 charge. Now, based on this understanding, I want all of you to start looking for magnesium element inside your periodic table. Can you tell me how many electrons do you think magnesium will have? How is magnesium represented inside your periodic table? This is how magnesium looks like inside your periodic table. And notice that there are 2 numbers associated with it. What do each of these numbers represent? Well, we know that the top number, 12, is the proton number of magnesium atom, while the bottom number, 24, represents the mass number of our magnesium atom. So based on the proton number, I know that my magnesium has 12 protons. How many electrons do you think it will have? Remember just now we said the atoms are electrically neutral, which means that they will have the same number of protons and electrons. So my magnesium atom will also have 12 electrons. And we can put all these electrons into electron shells, which are represented as boxes. Do you still remember the magic number to each of these boxes? It is 288. So what this means is that the first shell can hold 2 electrons, while the second and the third shell, they can hold 8 electrons. So let us try to distribute the 12 electrons of our magnesium atom into the boxes. So I know that the first box is very small and I can only fit 2 electrons. So I'll put 2 and that leaves me with 10 electrons. Can I put all 10 electrons into the second shell? No, the second shell only allows us to put in 8 electrons. So I'm left with 2 electrons that I will put into the last shell. Now by separating all these numbers with commas, I'm writing down the electronic configuration of our magnesium atom. So the electronic configuration simply refers to the arrangement of electrons. Now my next question to you would be, are all of these electron shells fully filled? Let's check it together. The first shell, how many electrons can it hold? It can hold 2 electrons. And how many electrons did I put in? I've also put in 2 electrons, which means that the first electron shell is fully filled. What about the second electron shell? The second electron shell can hold 8 electrons and I've put in 8 electrons. So it is also fully filled. The third electron shell, how many electrons can it hold? It can hold 8 electrons, but I have only put in 2 electrons, which means that the third electron shell is not fully filled. In other words, we can say that the magnesium atom is not stable. Now, what do you think the magnesium atom can do to become stable? There are 2 options. What are the 2 options? It can either lose 2 electrons or gain 6 electrons. Now, between losing 2 electrons and gaining 6 electrons, which one do you think is easier for the magnesium atom to do? It is much easier for it to lose 2 electrons. And at this point, it will become a magnesium ion. But there's also a formula to this magnesium ion. Because it has lost electrons, I will put a plus sign. How many electrons did it lose? It has lost 2 electrons. So I will add a 2 in front. I know that at this point, some of you might be a bit confused, but don't worry because we will do a summary now. We know that the atoms, they can either gain electrons or lose electrons to become ions. Why do they want to become ions? That is because ions are stable. In other words, all the ions will have fully filled electron shells. But how am I supposed to remember if an atom that has gained electron should become a positive or a negative ion? Well, I like to think of electrons as homework. So if your teacher usually gives you 5 pieces of homework and today she decides to give you 2 more pieces of homework, will you be happy or will you be sad about it? You will be very upset. So likewise for atoms, atoms that have gained electrons will turn into very sad ions. In other words, the ions will have a negative charge. Now, if on your way home it started raining very heavily and your worksheets got wet, so in a sense you have lost your homework, will you be happy or will you be sad about it? This time, you'll be very happy because there's less homework for you to do. So for atoms, those that have lost electrons will turn into happy ions, which means that the ions will have a positive charge. Now, I want all of you to take a look at the options given to us in the question. Can you identify for me which ions are happy ions and which ions are sad? Very easily, you would be able to tell me that the hydrogen, calcium, as well as lithium ions are happy ions because they all have a positive charge to it. Why are they happy? That is because they have lost electrons. Let us write that down. Now, between these 3 happy ions, which ion do you think it will be the happiest? I would say that the calcium ion is the happiest because it has lost 2 electrons compared to the hydrogen and the lithium ion which only lost 1 electron each. So our calcium is very, very happy because it has lost 2 pieces of homework and it has very little homework to do now. Which ion is the saddest? The fluorine ion is very upset because it has a negative charge to it. Why is it upset? That is because it has gained electrons. And how many electrons did it gain? It has gained 1 electron. So we know that all the options given to us here are ions and that ions come from atoms. So can you identify all the atoms that these ions come from? They are hydrogen, fluorine, calcium, as well as lithium. Now my next question to you would be, how many electrons do each of these atoms have? How do we find the number of electrons again? Remember we said that atoms are electrically neutral, which means they will have the same number of protons and electrons. And the proton number is simply the number that is at the top. So the answer should be 1, 9, 20, and 3. Now, let us try to write the electronic configuration of all these atoms together. In other words, we will fill in the electron shells now. Do you still remember the magic number? It is 288. So I want all of you to quickly draw 3 boxes to represent the electron shells of each of these atoms before we start filling them in. Starting with our hydrogen, we know that there is 1 electron. But do I put the 1 electron into the first, the second, or the third shell? The rule is to add electrons from the innermost shell first. So I will add the 1 to the first shell. What about fluorine? Fluorine has 9 electrons. Can I put all 9 to the first shell? No, the first shell only holds 2 electrons. And that leaves me with 7 electrons. Can I put all 7 into the second shell? Yes, the second shell can hold up to 8 electrons. Now, I want all of you to repeat this exercise for calcium as well as for lithium before we go through our answer together. So for calcium has 20 electrons. So after I put in 2 electrons in the first shell, 8 electrons in the second shell, and another 8 electrons in the third shell, I'm still left with 2 electrons, and I'll just put it at the back. What about for lithium? Lithium has 3 electrons, so the electronic configuration will be 2, 1. Let us now try to write the electronic configuration of our ions. How do we do that? Well, we know that our hydrogen atom has lost 1 electron to become an ion. So I will simply cancel the 1 and replace it with a 0. So the electronic configuration of the hydrogen ion would just be 0. What about fluorine? Fluorine has gained 1 electron, meaning I need to add 1 electron. But do I add it to the first shell or do I add it to the second shell? Well, the first shell is already fully filled, so I will add it to the second shell, and the electronic configuration would be 2, 8. What about calcium? Calcium has lost 2 electrons. Do I remove electrons from the front or from the back? The rule is to always add electrons from the front, but when you remove electrons, you have to remove it from the outermost shell. So I will remove the 2 electrons from the back, and the calcium will have the electronic configuration of 2, 8, 8. Lastly, for lithium, we know that it has lost 1 electron, so I will simply cancel the 1 from the back, and its electronic configuration would be 2. So the question is looking for an ion with an electronic configuration of 2, 8, and that would be our fluorine ion. So the answer should be option 2. But don't pause the video just yet, because don't you realize that this is a very tedious process of answering this question? I'm about to show you a shortcut. Now, based on our understanding of electronic configuration, we know that the 2, 8 means that there are 2 electrons in the first shell and 8 electrons in the second shell. So what do you think is the total number of electrons this ion has? It will simply be 2 plus 8, which is 10 electrons. Let us try to figure out the number of electrons each of these ions will have. How do we do that? Well, we know that our hydrogen atom has 1 electron, and it loses 1 electron to become a hydrogen ion. So the ion would have 1 minus 1 equals to 0 electrons. Moving on to fluorine, the atom has 9 electrons, but it gains 1 to become an ion. So the ion will have 9 plus 1, which is 10 electrons. What about calcium? Calcium atom has 20 electrons, and it loses 2 to become an ion. So the ion should have 20 minus 2, which gives us 18 electrons. Lastly, for lithium, the atom started off with 3 electrons, but it loses 1 electron to become an ion. So the ion will just have 3 minus 1 equals to 2 electrons. So by quickly figuring out the number of electrons an ion should have, I can confirm my answer to be option 2. Thank you for watching, and I hope you have enjoyed this video. If you found this video useful, do give us a thumbs up. If you would like to check out more videos by us, do click on the links on the right-hand side. Last but not least, don't forget to subscribe to our channel for more interesting videos. Thank you, and I'll see you next time. Bye!